actually talking about lesson 4, which is, gosh, what was lesson 4? Something with quadratic equations. Oh, completing the square to solve quadratic equations. So we're going back to kind of graphing again. And the reason we're going to go back to graphing is because completing the square puts a formula or a quadratic equation into vertex form. Now remember, vertex form was y equals a parentheses x minus h parentheses squared plus k. And remember, your vertex is h comma k. And A tells you, you know, how about your vertical stretch or your vertical compression, or if you reflect over the x or y axis. Okay, so the reason we're going to tie completing the square into graphing it and finding vertex form is because that's what you have to do. So take a look at this first example. We are in standard form because you start with the x squared, then you have x, then you have minus 10. It's in decreasing order. So if you take this, and now notice the y stays y, you don't make it 0, but we're going to move the constant to the other side, so it's y plus 10. Now complete this square, so adding 4 to both sides, so the 10 becomes 14, and now we have a perfect square that you can factor x plus 2. Now subtract that 14 and bring it back, and we are in vertex form. So right here, h is negative 2 and k is 14, so your vertex is negative 2 comma 14. And then you can solve that equation to find out, or to approximate your x-intercepts, your solutions, which is what they did. They took the square root of 14 plus or minus and then subtracted 2, and they got negative 5.74 and 1.74. And then you could sketch your graph using your vertex and your x and y intercepts. So it's just one more use. We're kind of tying all of these skills together, and we're going to continue to use them. All right, and remember, your vertex always gives you your axis of symmetry. It's always, so in this case, it would have been x equals negative 2, right? Right here is your axis of symmetry. So let's go down here, and we can always tell, they're saying finding a maximum and a minimum, because that is finding the y value of the vertex. So in other words, k, right? K in your vertex. So take a look at this one. We've got a negative x squared plus 6x minus 5, so they added the 5 over. They divide, or check this out, they actually factored out a negative 1, okay, because that is your a. And then in here they're going to complete the square, which would be adding 9, but because that is a negative out front, notice it becomes a minus 9 over here. Don't worry, we're going to practice this. And then here you have, that becomes negative 4, so we add a 4. So your vertex is 3 comma 4, and it is opens downward, so this is a maximum value. So your axis of symmetry is x equals 3, and your vertex is at 3 comma 4, which means your 4 is your maximum value. You can solve by completing the square and taking the square root, and you get 5 and 1 as your solutions. All right, so what do you need to complete the square and to write the equation of a quadratic function in, or why do you need to complete the square? Well, you know, you need to complete the square because you need to put it into a binomial that is squared. And in order to, you need the binomial squared to put it into vertex form. And so you need this right here. So you have to complete a square because you need a squared binomial in there. All right, so let's turn this page over, and this is right out of the textbook, but you are going to need some graph paper, and you are going to need some paper to show your work. All right, so let's just, I'm in this space right here. You should do it on a separate sheet of paper, on a notebook paper, but I'm going to do it right here so you can see it. We're going to do number 2. So write each one in vertex form. So first we are going to, this one already has, it does not have a constant, so I don't have to move it to the other side. I can right away complete the square, which would be half of 6 is 3. Squared is 9, so we're going to add 9 to both sides. Now I have y plus 9 equals, and if I factor it, x plus 3 squared. And last but not least, y equals x plus 3 squared minus 9. All right, so identify the axis of symmetry. The axis of symmetry for this one would be x equals -3, because the vertex is -3 comma -9. The extrema would be a maximum or a minimum. In this case, this is the minimum. The minimum value is -9, because that's our y of the vertex. And then the last thing, the zeros, we need to solve it to get the zeros. So coming over here, you're probably going to need a lot of work, a lot of room. So solving this one, so 9 equals x plus 3 squared. We're going to take the square root. So plus and minus 3 equals x plus 3. We subtract 3. We get -3 plus and minus 3, so our answer is x equals 0 and -6. And last but not least, graph the function. And you should be able to graph that function pretty quick. You may have to go by 2's on your coordinate plane, but here's your vertex, there's your line of symmetry, there are your 2 zeros. You can probably plot your y-intercept real quick if you want to add another point, but that's what you're going to do. It shouldn't take very long. I know you're probably thinking it's going to take forever. I got 9. Well, technically you only got 8 to do, because we already did 9. And just for the sake of doing another one, let's look at number 3. Actually, you know what? I'm not going to do number 3. Let's do something where we've got to factor it out. Let's look at number 8. Okay, I'm going to put that work down here. Number 8 is y equals -4x squared plus 16x minus 11. So my first step is going to be add the 11 over here. So y plus 11 equals -4. Now I'm going to factor out a -4 out of these two, because I need it to be x squared. So it's x squared minus 4x. So completing the square, half of -4 is 2, squared is 4. So in here, plus 4. But remember, I'm just adding the plus 4 in the parentheses, so I have to multiply it by that, which would be a -16. So we are going to subtract 16 from the other side. So we get y minus 5. So now I'm factoring y minus 5 equals -4, x minus 2 squared. Add the 5 over here. And here's my formula. Let me slide it up for you. So I now know what my vertex is. First of all, my vertex, not that they asked me, but it is -2, 5, right? I also know that it is the axis of symmetry is simply x equals -2. I know my maximum value, because this thing is going to open downward, so my maximum value is the y of my intercept, so is y equals 5. And then I need to find the zeros, which would mean I go back to my original right here and set it equal to 0. So I've got 0 equals -4 x minus 2 squared plus 5. So -5 equals -4 x minus 2 squared. I have to divide by -4. So I get 5/4 equals x minus 2 squared. I'm going to take the square root, positive and negative square root of 5 over 4. And then we're going to add 2. So x equals 2 plus or minus the square root of 5 over 4. And I'm going to let you get the approximated values for that. They are going to be, 3 point something, I think, and, negative, or I'm not sure, 3 point something and 1 point something. We'll see how that goes. And your vertex is x equals negative 2, y equals 5. So plot those and graph it and give your approximation. All right, this last one is a word problem, but you should be good. You've dealt with this before. They're asking you to graph it, but they're asking you basically to do the same stuff we've been doing. All right, I will be around. Come see me if you need help. Good luck.